sorry, NH4 plus. So here we go. Get back to, okay. B can be mono or di atomic. Example here is the Cl. An example here is the CO3 2 minus, or the carbonate. Right? So if we replaced A with a diatomic, we would have, say we had NH4 plus, and we want to combine it with CO3 2 minus. What are we going to get? Remember, we could always use this little trick. You bring those over here at the bottom. So what our compound is going to be is NH4 2 CO3, just like that. So this is still just from stuff from one of the very first chapters that we did. So remember, now the balances are charged. There's two NH4s, which each have a charge of +1, and CO3 has charge of 2 minus. So overall, the charge is going to be 0. So this is our compound. And then the same thing, it breaks up into NH4 plus CO3 2 minus when we have that in water. Right? Now, some of you guys asked me for charges of certain atoms and ions. So this is another example here from assignment 2. And all these are right here. These are on assignment 2. I'm pretty sure they're in assignment 1, and probably even in assignment 2 or 3. Maybe not though. So you could combine any one of these. So say if I grab this over here, bring this over here, you could combine hydrogen, Cl, Al, aluminum and O2, cesium and sulfur, whichever. So if you combine H and Cl, you get HCl. You combine cesium and sulfide, you get that. You combine aluminum and oxygen, you get this. Right? So remember, it has to do with the charges. So 3 plus and 2 minus will go to the opposite atoms, and you get your compound. But yeah. So that's what ions are, and that's how you kind of make them up. So then if you have an equation or reaction, not very straight. If you have one of these, or they're the same thing basically. So you could have anything. You could have AB plus CD now. So A is the cation, right? B is the anion, this is the cation, anion, and then basically what you're going to get as products is you're going to get this. Right? So your positive and negative are always going to go together, and same thing over here. Right? So that's the reaction that takes place. And just like the ions, you could replace A and B with anything from here, as long as they're the right charge. So this could be NaCl plus, grab any, like I said, anything. Let's go with Mg2 plus and S sulfide. Mgs. And our products are going to be this, MgCl2. Now you notice here that there's no 2 and 2 here. It's because you could reduce that down. It's just like you don't show 1. Basically, if you divided this by the entire thing by 2, you get Mg1S1, because remember, it's about polar ratios. So this compound takes 1 magnesium per 1 sulfur. And if it's